I'm Juan Carbonell.
I'm Cari Geldreich.
I'm Suheil, Arafeh.
And we did our tachometer / mixture control knob for an RC airplane.
For my part, I was responsible for getting the keypad and downloading the libraries for the keypad and seeing how it's wired, like which pins go where. I used a lot of online references as far as writing the code for the keypad, and I helped wire the keypad with the other components in the Arduino. We ran into a problem with the IR sensor because it wasn't reading RPMs correctly. So I went and got another IR sensor, and then it worked. So what I learned from all this is how IR sensors work, just how the air-fuel ratio affects the engine, and how easy it is to look up code references for components, and then how to put everything together.
So I was responsible for programming the LCD screen as well as helping out in the testing phase, which is setting up and starting the airplane. And what I learned about the I2C protocol, which has two components, the master and the slave. And from that we realized that because we had so many connections, we were from the keypad and LCD to Arduino, we were short on 2 connections. So that led us to buy the Arduino Mega.
So I was responsible for setting up the tachometer code and the menu navigation. It involved using the I2C libraries, which Suheil downloaded for the LCD, as well as using a keypad function that Cari helped write. There's a lot of resources online for tachometers using Arduino. I found that the best combination was using attaching interrupts and using non-blocking code, because in this case we needed a continuous loop for reading the RPM. The problem that we faced the most was menu navigation, how to find the max RPM or input using the keypad so that the LCD worked, the keypad worked, and the tachometer was constantly working in the background. So with Cari and Suheil's help with the libraries, we were finally able to get everything working without conflict. The following clip demonstrates menu navigation. Here we go from displaying the current RPM at option 4 in the main menu to changing some of the settings. First setting to be changed is the servo range. The user inputs an even value and the servo sweeps that range in both directions. Next, the user is inputting their own RPM. Here they input 10,000. The servo sweep begins, displaying the position of the servo and the instantaneous RPM. After it's done with the sweep, the program displays the target value as well as the closest value achieved. Here the user demonstrates selecting the maximum RPM. The engine is not running, so the RPM value is read as 0, but the servo position is shown. Here we have a clip of the servo at twice the speed. The servo is in the process of completing the sweep for the maximum RPM. Overall, the project proved to be successful. We were able to meet all of the required goals and follow the guidelines provided by Dr. Furman. Had time allowed, we would have researched the possibility of wireless capability. However, since menu conflicts held us up, we had to settle for what we could during the given time frame.